All right, hi guys. We are looking at the next part of finding the distance of our line segments. Yesterday, the last time, we looked at distance when it was just on a single number line. Now we're going to see what happens when that same segment is now put on an XY plane, a graph. So we're going to look at two ways that we can find the distance. So we can find the distance between 2 points on the coordinate plane by drawing a right triangle and using what's called the Pythagorean theorem. Now, guys, you've heard of Pythagorean theorem before. And I'm going to abbreviate that, Pythagorean theorem. That is the formula that we all know and love so much that says a squared plus b squared is equal to your c squared. And in this case, the c is our distance, or in this case, our segment that we're trying to find the length of. All right, so how do we know which one to let be the A, which one to let be the B? So for us, for now, for our notes, we're going to let the flat side be the A. We'll let the vertical side be the B. And of course, your segment, which is the one that we're actually trying to find the length of, is C, which is just a C, not a C squared. So let's take a look. We're going to jump down and do an example real quick of the Pythagorean theorem, and then we'll come back up and look at the next way. Whoops. All right, so example 1. Find the length of AB, because remember, no symbol on top of those letters means the length of. So find the length of AB if A is at 4, -2. So I'm going to graph that 1, 2, 3, 4 down to -2. So there is A, and B at 1, 2. So this is the segment we're working with. So like it says, we're going to use Pythagorean theorem for this one. So we're going to draw the right triangle that's using this as a C. So there is our C value. So here's my flat side, my A, and it's going across 3 squares. So A is a length of 3. My B side is vertical, going across 4 squares. So my B is a 4. So let's see what we get when we plug these 3 numbers into our formulas. All right, so first thing I need, A squared, so 3 squared. We're going to add to that B squared, which was a 4, so 4 squared. And it's supposed to equal C squared, and that's what I've got to figure out. So let's do the math and see what we get. So 3 squared, 3 times 3 gives us a 9. 4 squared, 4 times 4, a 16. And I'm still trying to find C squared. So let's keep going. 9 plus 16 gives us 25 for C squared. But remember, I need the C for my distance. So this is where we will have to do a little bit of a solve. I need to square root both sides of this equation in order to figure out what my C is. So right now, my C is the square root of 25, which means what number multiplied by itself gives me 25, and that answer is a 5. So when I go back to my point, the length of AB is 5. So now I've gone back to my segment, and I know my length. And that's Pythagorean theorem. Now let's check out our next formula that we can use, because it's also related to Pythagorean theorem. This one is our distance formula. Now you did use this one in Algebra 1. So it might have been a little while. You might have used it in Algebra 2. But I know it has been a while since it was used. So let's take a look specifically at our formula. So this time, our formula says the distance is equal to a big square root here, just like Pythagorean theorem. We had to square root at the end. This time it starts off with the square root. X sub 2 minus x sub 1 squared. That looks very much like a squared. Plus y sub 2 minus y sub 1, which looks kind of like b squared. Now, where are those x1s, y1s, x2s, y2s coming from? Well, if you remember your slope formula, we have 2 points, just like we did for Pythagorean theorem. And those 2 points are what represent x1 and y1, x2 and y2. Now, it doesn't matter which point you want to be which, you're going to get the same answer either way. So now let's try that same example as before, but now using the distance formula. So I have my 2 points. I have my A and the B. And so now I'm going to label these so I can remember which is which. I'll make this just a little smaller. My x1 and y1, my x2 and y2. And again, if you label these the other way, you're still going to get the same answer. So let's see what happens now when we put these into distance formula. So I need a big square root. All right, we start off with x sub 2, which is a 1, minus x1, which is a 4. And then we'll square it, plus we'll do the same thing to the y's, y2. So that's a positive 2 minus y1, a negative 2. And then we'll square these. So let's see what we get. Let's keep going here. 1 minus 4, that is a negative 3. And then we'll square that in a minute. 2 minus negative 2. So just keep in mind, minus a negative becomes a plus. So this is the same as 2 plus 2, also known as a 4. And then we'll square it. Let's keep going. All right, negative 3 squared. That's the same as negative 3 times negative 3, so positive 9. Now, guys, if you're going to put that negative 3 squared in a calculator, you must use parentheses because you're dealing with negatives, okay? That's a requirement. Otherwise, you might run the risk of getting the wrong answer. So make sure you put parentheses around a negative number when you're dealing with exponents. So now let's keep going here. 4 squared, 4 times 4, a 16. Guess what? That looks pretty similar to numbers we already saw. Yep, down there towards the bottom, 9 plus 16. So I have the square root of 25. So now I know that the length of AB is 5. So either way, we get the exact same answer, regardless of which formula you choose to use. So let's try those 2 formulas on a couple more examples so that we can get the practice. All right, let's check out example 3. This one is Pythagorean theorem. So we'll need to draw a graph for this so we can count out your A and your B. So I need 5, negative 6. So that's going to be down towards this corner. And now I have 1, 2. And that is the C length that I'm going to try to find. So let's make your A and your B. So there's my A going across 4 squares. And there's my B going across 1, 2, 3, 4, 5, 6, 8 squares. All right, let's put these in Pythagorean theorem and see what we get. All right, so again, A squared plus B squared equals C squared. All right, let's do our math here. So my A is a 4, so I'll need 4 squared. B squared is an 8, so 8 squared. And C is what I'll be left with, C squared. Let's keep going. So 4 squared, 4 times 4, 16, plus 8 squared, 8 times 8, 64, is our C squared. So let's add those 2 up. 16 plus 64 gives an 80. And now I can square root both sides. And so my distance, my C, is the square root of 80. So in the calculator, we get about 8.9. So we're going to round this. And guys, I want you to round to 1 decimal point. So we're looking at about 8.9. Now, really, we'll end up getting 8.9, and then the form, it continues. Okay, so just remember, if we're rounding to 1 decimal point, you need to look to the second digit to see if you need to round up or down. Remember, a 5 or higher, round up. 4 or lower, round down. So let's go straight down and try another one with Pythagorean theorem to get our practice here. So now we have -2, -1. So there's our first point, and 1, 3. There is our second point, and so that will be our C. Let's get your A and B. All right, A, we're looking at 3 for our A, 3 squares. B, we're looking at 4 squares. So let's try Pythagorean theorem for this one. So 3 squared plus 4 squared equals our C squared. All right, so again, 3 times 3 gives us a 9. 4 times 4, a 16. For our C squared, 9 plus 16 is what? 25 again for C squared, and then I can square root both of these. And my distance is 5 units. All right, so guys, I hope you're feeling comfortable with Pythagorean theorem. Our other 2 examples on this page are dealing with the distance formula, so we're going to give those a try. All right, let's go ahead and label these x1, y1, x2, and y2. So let's put these into our formula. All right, so I need x2 or -2 minus x1, which is an 8. And then we'll square that, plus y2, which is a 3, minus y1, which is a 1, squared. Now, one thing you can do, guys, you can put this straight into your calculators exactly the way it looks. All right, with the big square root, with the parentheses and the exponents in one big step. So guys, if you want to hang around, I can show you how to put all of that in your calculators if you come into the Zoom meetings today. Because I don't recommend you using a phone calculator for these. All right, so let's see now what we get. -2 minus 8 is a -10, and then we'll square that, plus 3 minus 1 is a 2 squared. So let's keep going and see what we get. All right, so now we have -10 squared. So -10 times -10, positive 100. 2 times 2 is a 4. So I need the square root of 104. And again, if you're waiting until the end to put this in your calculator, this means my distance is about, again, you'll get roughly 10.1 something. We'll round this off to 1 decimal point. So 10.1. All right, one more example with distance formula. I want to make sure we're good here. All right, again, let's label x1, y1, x2, y2. Okay, let's plug it in. Our big square root. So I need x2, which is a positive 1, minus x1, -5. And then we'll square it. Now let's do y. So y2, a 1, minus y1, which is a 0, and then square it. Let's keep going. All right, again, notice we have a minus negative in that first set of parentheses, which turns out to be the same as an addition. So 1 minus -5, same thing as 1 plus 5, so I get a 6 squared. And 1 minus 0 is a 1, and then we'll square it. So let's keep going. 6 squared, 6 times 6, 36. Plus 1 squared, 1 times 1 is just a 1. So the square root of 36 plus 1 is a 37. So square root of 37 gives us about, and again, we're going to round this off to 1 decimal point, about 6.1. So again, guys, before I leave, I do want you to see what those values look like in our calculators, so that you can see that, yes, we do in fact need to round here. So this last one, notice square root of 37 is there. This last row, and there's our final answer, 6.08. So again, because I'm rounding to 1 decimal point, I need to look to the second digit after that decimal, which is the 8. Because 8 is bigger than 5, it's going to make that 0 round up to the 1. So that's where we're getting 6.1. All right, so guys, I hope you enjoyed learning a little bit about finding the length of a segment when it's on a graph. You've got two options, either Pythagorean theorem or distance formula, whichever one you choose to use. If you have any questions at all, guys, please make sure to check into the Zoom classes. And I hope you guys have a great rest of your day. Bye.